Okay, so we're going to look at, I suppose, one of the other uses of integration. So beyond area and calculation of area, the other use that we have is really for calculating the average value of a function over a specific interval of x values. So the average value, fairly simple, it's 1 over b minus a times the integral from a to b of the function, okay? I suppose the key thing here is that this is something that you would need to know. Okay, this is not something that would be given in your formula and tables book. This is something that you would need to know of. So just to kind of know that already for yourself. So first question, find the average value of the function f of x equals 2x squared plus 3x minus 1 on the interval 1 to 4. So to find the average value from 1 to 4, we're essentially saying a is 1, b is 4. So we're doing 1 over 4 minus 1 integral from 1 to 4 of 2x squared plus 3x minus 1 dx. Okay, so that's a third times, and then we'll do our integral. So that is 2x cubed over 3 plus 3x squared over 2 minus 1x to be evaluated at 1 and 4. So I suppose sometimes what comes in here maybe is just being very careful about how you lay everything out. So the third here is going to be multiplied by the overall answer. You could do the integral first and then multiply it by the 1 over b minus a if that was just going to keep things cleaner for you. It'd be completely up to you. So let's go with both of these. So 2 times 4 cubed over 3 plus 3 times 4 squared over 2 minus 4, of course, minus 2 times 1 cubed over 3 plus 3 times 1 squared over 2 minus 1. Okay, and let me see what that's going to give us then. A third times 188 over 3 minus 7 over 6, which gives me an overall answer of 41 over 2. So what that really means for my function here, it's a quadratic function, a positive quadratic function. So I suppose just following the usual kind of format or view for a positive quadratic function. And it basically just means that the average value that this function takes across this specific interval is 41 over 2. Okay, in terms of y values, I suppose, for that function there. Okay, second question, find the average value of h of x over the interval 0 to pi over 4. Okay, so what we would need to be careful about with this one, I suppose, is going to be making sure that we keep our calculator in radians mode. So obviously my calculator here is slightly different to your own one, but just making sure it's in radians mode for when you're doing the calculation here. Now I can see immediately that I don't have the actual function written in here for myself, which is not very helpful. So the function cos2x. So let's do this integral. So we're doing 1 over pi over 4 minus 0, integral from 0 to pi over 4 of cos 2x dx. So that is going to give me, let me see, 4 over pi. Okay, so that's the 1 over pi over 4. So remembering that idea, we'll take it to the side here. It's essentially 1 divided by a pi over 4, which is 1 multiplied by 4 over pi. Okay, so I suppose that's our quick way. We also just have that idea of when we have a fraction on the bottom of a fraction, the denominator will be multiplied onto the top there. So there's different ways of remembering that idea if you're unsure. So looking at integrating our function here, first of all, our cos 2x. So cos 2x is going to go to, let me see, so cos is going to integrate to sine 2x because sine would differentiate to cos, and we also need divide by 2 because we would normally multiply by the derivative of that angle there. So that idea of always doing integration as the reverse of differentiation and just essentially doing the steps backwards. So 4 over pi sine 2 times pi over 4 over 2. Okay, we could also think of that as a half sine 2x. Okay, we could also think of it this way, that's the same idea. And then minus sine 2 times 0 over 2. Okay, so evaluating both of those, that's 4 over pi times, let's see, so sine 2 times pi over 4. I would say be very careful about how you're inputting this function here. You want to make sure that the overall bracket that I press after pressing sine, so the way I've done it here, after pressing sine, that I include both the 2 and the pi over 4 in that bracket. We have to be careful about our use of brackets here. I would generally say either do it like I've done there and ensure that we have the correct number of brackets, or open and close your brackets straight away and then include any subsequent brackets that you need as well. But just to make sure that your calculator doesn't accidentally think you're doing sine 2 and then multiplying that by pi over 4. It's just to be kind of careful about those things. Even having an idea as well, pi over 4 times 2 is pi over 2, so that's essentially equivalent to 90 in degrees, which should be one of those key values for my sine function. Anyway, all of this to say, putting all of that, it's sine 2 times pi over 4 all over 2, so that's going to be a half, minus, and then we can replace that one out with 0. We're kind of expecting sine of 0, we already know is 0, so just 0 overall. Okay, so we get an overall answer then of 2 pi, Okay, and give your answer in terms of pi. We've done so. Okay, we'll look at now how that could apply in context questions, because the use of average value, or questions where you'd be asked to calculate average value, are often, say, those later questions in the exercises where you've maybe done all the hard work, or I suppose maybe those calculus questions and the long questions in the second section B, the context and application. So you might be doing a calculus question, and then partway through, one of the parts of the question could just be calculate the average value of this function. So it could be the average profit, it could be, as we see here, the average height that the rocket is above the ground. So there's a number of different ways. We'll see some more even in the examples we get into, but just to know that it can come up in that sort of way as well, maybe as a smaller part in a longer question, as opposed to just being its own question. So a rocket is launched vertically from the ground. The height of the rocket in meters of the rocket time t is given by the function. So we're looking at a negative quadratic function, which kind of makes sense. We're expecting that it's launched here and then it lands at the other point here. Okay. Determine the times at which the rocket is at ground level. Well, ground level is going to mean that the height is 0. So the y value of the function is 0. So we want to find t when h of t equals to 0. So minus t squared plus 8t equals 0. We'll factor out minus t. So being careful here as well that we can never just divide across by t, because t is a variable. We can't just divide across by a variable, particularly in a function where that variable has real meaning. So we need to factor that out and account for the fact that if that variable is able to be divided by, that essentially just means there's a factor of 0, that t is equal to 0. Okay, making sure as well here that negative when I factor that out. So we're getting minus t equals 0, or t minus 8 equals 0. So t equals 0 and t equals 8. Okay, so at 0 and 8, my rocket is at the lowest point, which makes sense. Starts at 0, at time 0, starts on the ground, hits the ground again when t is 8. Find the average height of the rocket above the ground during that time interval. So that's 1 over 8 minus 0, integral from 0 to 8 of minus t squared plus 8t dt this time, because t again is our variable. 1 over 8 minus t cubed over 3 plus 8t squared over 2, which of course would just be 4. 0 to 8. So let's compute this integral this time. So minus 8 cubed over 3 plus, we'll reduce this to 4. So 4 times 8 squared. And then minus 0 cubed over 3 plus 8 times 0 squared over 2. So as all of that's just multiplied by 0, that's just going to go to 0 anyway. So let's continue working out our answer here. So 1 over 8 times 256 over 3, which is going to give me an answer of 32 over 3 meters. So it has an average height of about 32 over 3 meters across its flight here, I suppose. Okay, so we'll just get into then the last few questions here, just some exam questions, primarily to see this idea of the context and how it could be asked in some of those longer questions, really. We've, I think, three exam questions here to consider. So first one, short question. The slope of the tangent to a curve at each point is 2x minus 2. The curve cuts the x-axis at minus 2, 0. Find the equation of f of x. Okay, this is the slope of the tangent, so essentially they're telling us this is the derivative. So they're saying the derivative of some curve is 2x minus 2. Find the original curve. Well, we should hopefully know, since it's kind of the main definition of integration, is that the original function is the integral of the derivative function. So we need to integrate 2x minus 2 dx to get 2x squared over 2 minus 2x plus c, because we aren't giving any bounds on my integral, so we have to remember that until we know more information, this is still kind of one of those indefinite integrals, because I suppose it's in the name. We can't be definite of our answer until we know that case. Now we are given more information here. We're told that at the x-axis, it cuts the x-axis at minus 2, 0. So that means that f of minus 2, which is minus 2 squared minus 2 times minus 2 plus c, should be equal to 0. So that's 4 plus 4 plus c equals 0, which means c is minus 8. And my function f of x is going to be x squared minus 2x minus 8. Find the average value over the interval 0 to 3. So we're doing 1 over b minus a, interval from a to b of f of x dx. So let's fill in all our values here. That's 1 over 3 minus 0 from 0 to 3 of x squared minus 2x minus 8, and the integral with respect to x, 1 over 3 x cubed over 3 minus 2x squared over 2 minus 8x evaluated at 0 and 3. So that's 1 over 3 times 3 cubed over 3 minus 2 times 3 squared over 2 minus 8 times 3 minus, and looking at this already, I'm going to be subbing 0 in for every value of x here, which essentially is just going to reduce down to 0 anyway. Okay, so we'll fill in some of these values here. So that was 3 cubed over 3 minus 2 over 2, which is just 1, of course, 3 squared minus 8 times 3. What am I doing? Minus 8 times 3, which is giving me an answer of minus 24. And of course, as I said, the other part is just going to go to 0, so that'll give me an answer of minus 8. So the average value of the function across this range is a value of minus 8. Okay, got it. Absolutely, that's perfect. Okay, let's continue onwards then. An inflated ball is kicked into the air from a point O on the ground, taking O as the origin. This function approximately describes the path followed by the ball in the air. Where x and f of x are measured in meters, find the values of x when the ball is on the ground. Okay, so let's have a look at this one. So the ball on the ground, that's going to be where f of x is equal to 0. So that's minus x squared plus 10x equals 0. Again, very, very similar to the one that we just did as an example. We get that x is 0 and x is 10. So those are the two times when the ball is on the ground. Average height of the ball on the ground. Again, this is very, very similar to our example here, I suppose. So we just kind of fly through it. The only change here actually just is the 10. So let's see, minus x cubed over 3 plus 5x squared. So just kind of jumping the gun a little bit there on that one, just to speed us up. So minus 10 cubed over 3 plus 5 times 10 squared, and then so that's my 10 part, and then the other part is just going to give me 0. Okay, if I fill in 0 for everything for x, it's just going to reduce down to 0 then. So continuing onwards, that's going to give me 500 over 3, which is 50 over 3 meters as its average value. Okay, last little question here, another example or good example of what I was saying there of how this could come at the end of a question. We have a trig question here, question 9, so long question, trig function. Approximate length of the day in Galway measured in hours from sunrise to sunset may be calculated using this function, where t is the number of days after March 21st. And 2 pi over 365t is expressed in radians. Use integration to find the average length of the day in Galway over the 6 months from March 21st to September 21st, which is 184 days. Give your answer in hours and minutes correct to the nearest minute. Okay, so we are basically being asked here to find the average value for 184 to 0. So 0 to 184, and we're integrating this trig function, okay? Probably, I suppose, one of the more difficult integrals that we've encountered across all of these questions here. It's the kind of the most intricate, okay, dt. So let's just be careful with integrating it then. 1 over 184 minus 0, of course, just gives me 184. 12.25t. So integrating that gives me the t value. Okay, the 4.75 stays as is. Sine will integrate to minus cos. Minus cos 2 pi over 365t. So we integrate the sine part. Okay, so let's kind of mark these in. We integrate the sine part to get minus cos to get all of this. And we also then need to divide by the 2 pi over 365, because we consider the fact that if I was differentiating, I would multiply by that. So to integrate, I need to go the opposite way. The quickest way then to consider it is just to try and go backwards then. So if I differentiate this expression, then minus cos would go to positive sine, and I would multiply by the 2 pi over 365, which would cancel it out on the bottom there as well then. Okay, but I don't need to change the power of the t or anything like that. I can leave it in this format. We'll tidy it up a little bit, obviously, but for all intents and purposes, we can kind of leave it in this format. Just color this in white just so we can keep going a little bit more. So 1 over 184, 12.25t, absolutely perfect. And let's see how we can reduce this down. 4.75 divided by 2 pi over 365 gives me 6935 over 8 pi. So let's go with that. Take the minus from the cos as well. So let's try that. So minus 6935 over 8 pi cos 2 pi over 365t. Okay, so we're just kind of incorporating everything here. Now, also need to be careful as well, because I know I've done it in a few examples there. When we've had 0 as a value to input here, a lot of the time I've just been saying, and that's going to give us 0. That's primarily because we're working with x's or t's or normal variables. When we're working with trig functions, we should know that values of 0 can actually give us actual values in a trig function, so we don't disregard them in that way. So 1 over 184, let's have a look. So 12.25 times 184 minus 6935 over 8 pi cos 2 pi for 365 times 184 minus 12.25 times 0 minus 6935 over 8 pi cos 2 pi over 365 times 0. So let's see what that will give us then. Keeping my 1 over 184 out on the outside here until the very end. 12.25 times 184, just be careful of inputting this, minus 6935 over 8 pi times cos, again being careful with my brackets here when it comes to cos, 2 pi over 365 times 184, close that bracket and the extra bracket as well. So we get 2529.8429 minus, let's replace now the 184s with the zeros. Okay, be careful doing this as well in an exam, because there's always a chance that what you've inputted in the first place was incorrect. So you just always have to be very, very careful with all of this. So let's go 1 over 184 times 2529.8429 minus 275.9349. So that gives me 2805.778. Or sorry, excuse me, there's another 7778. And I will multiply, again, this is kind of calculator work now from this point. 2805.7778 gives me 15.248792. Okay, so that is a fraction of days. We'll take this over to the side here to consider our conversion. 248792 days. Okay, so if we want to convert this then to hours and minutes, or sorry, excuse me, that is hours. That is hours, excuse me, that's the measured in hours. So that's hours. Okay, if we want to convert this to minutes, okay, we have 0.258 converting that to minutes gives me 14.927, which of course is around about 15 minutes. So we can take that as 15 hours, 15 minutes. The alternative way is to use our calculator. So type in 248792, and to use the button that I can't really highlight here, can I? So it's this button here, if you can see it glowing there. This one here with the kind of degree symbol and then apostrophes. So mainly used really for degrees and talking about minutes, seconds, etc. in angles, but you can also use it very usefully for time. So we can see here it's saying it's 15 minutes, 14 seconds. It breaks it down, I suppose, into the smaller intervals because it measures in 60s. So 15 hours, 14 minutes, 55 seconds, but to the nearest minute, that's going to be 15 hours and 15 minutes. Okay, so I suppose generally what we're saying here is application across all your questions, particularly those longer calculus questions. And the main thing then as well is that you would need to know the formula and recognize that if they mention average value, they're looking for integration there as opposed to any other kind of idea of average you might have. Again, same with area. Integration here is going to be more accurate than you just taking, say, a mean of the values. The integral is going to give you a much more accurate measure of the average value of that function.